2 and 1. All right, so let's have some fun, or some pain, I guess. So this is a quiz basically on linear systems. It's a little bit harder quiz. I purposely made kind of the questions a little bit tougher so that it really tests your understanding. So it's not very difficult in terms of the concepts. There's really just one concept, and the concept is you have two equations, two unknowns, and you have a couple of word problems which deal with exactly two equations, two unknowns. So let's get to it. If you want to download this particular quiz, okay, you can do so. You can open the show notes, and when you open the show notes, you can take the whole quiz, try it for yourself, and then come back and then do the solutions. Now, I have talked about all of these different things and the items that you need in order to solve these questions, and this is now just taking you a little bit to a further level to see your understanding. So the entire playlist related to these linear systems for the grade 10 side at least, okay, so I'll put up a link up above there, and you can search my channel for more on pretty much every topic on this. So let's look at the first question. So the first question, so I just copied it down here. Notice it has decimals and it has fractions. So we don't necessarily like dealing with decimals and fractions. I mean, it's not the end of the world, but you can always change and get rid of decimals and get rid of fractions if you want to deal more with whole numbers. Okay, so that's what I'm going to do first. Now, on the quiz, it says use substitution method and elimination method. I'll kind of just pick one and then solve it for you. You can try the other one, and then maybe I'll alternate between the questions so that you see both methods. So in the first example, to get rid of the decimals, so notice what I have is I have one decimal spot here, two decimals here, and then one decimal here. So you can easily just multiply by some number the entire equation. Sometimes it's convenient. Most of the time you can just do it multiplications by tens, and then you'll get what you need. Now, since I have two decimal places, okay, here, so I'm going to multiply this by 100, this entire line, and that entire line multiplied by 100 is going to give me, okay, the following. So I have, so 0.4 times 100, so that's now all of a sudden going to be 40x, so there's going to be 12y, and this is going to be 250. So that's what we have. We have no more decimals. Now I do notice, so 40, 12, and 250, because these coefficients here can still be reduced in some way. So notice I can divide by 2. All right, so I'm actually going to do that just so that I don't deal with as big numbers. So 40 divided by 2 is 20x plus 6y is equal to 125. So you just get a little bit smaller coefficients there instead of the bigger ones. You don't have to do that, but that's what I notice. Now for the second one, so what I'm going to do is, because these ones have fraction coefficients, so what I like to do is I like to just see, okay, so we have 3 and 2, and then you can just multiply by the lowest common denominator, or multiply by the lowest common multiple. So between 3 and 2, if you've forgotten the lowest common multiple stuff, put up a link up above there. All right, so I can multiply this by 6, and that's going to get rid of, okay, these two. So multiplying it by 6, what I get is, so that 3 goes into 6 2 times, so I'm going to get 4x, minus the 2 goes into the 6 3 times, so that's going to be 3y is equal to, now, and that's going to be, so right here, so this is going to be 6 over 10, which is just 3 over 5 in reduced form. All right. Now, if I didn't want to have that 3 over 5 there, I can, of course, try to multiply this thing and just to get rid of that 5 in the denominator entirely. So I could get rid of that by just simply multiplying by 5. So let me do that. All right. I could have done that right in the beginning. Okay, but that's okay. So if I multiply this line by 5, now I'm going to get 20x minus 15y, and that is then equal to 3. All right. So my two lines, which kind of looked crazy, it basically look like this. 20x plus 6y is equal to 125. And then now my second line is 20x minus 15y is equal to 3. Okay, so this is what I have there. And now, I mean, right away I kind of see, I like using the elimination because I have the same coefficient. Now this was just a fluke, all right? But because these are the same coefficients, I can just go ahead and just subtract these two lines from each other. So that's going to give me, so that is going to cancel, and then 6 minus the negative 15 there, that's going to be 21y is equal to, and I guess this is 122. So now dividing both sides by 21, that gives me my y. So my y is equal to 122 over 21. Now, can I reduce this? I mean, I guess I can check. 21, okay, the prime factorization is 3 over 7. So does 3 go into 122? Well, it's going to be 5, so no. And then does 7 go into 122? I don't believe so. So let's take a look if we can actually reduce this any. 7 into 12, so that's once. And then that's going to be 52. Yeah, so it doesn't go. So we'll leave it, okay? So we'll leave it as that particular fraction. Now, if you want to work with decimals, you can. The only problem is, you'll notice as usual, not as usual, but oftentimes, so there you go. You get some ugly decimal that you got to work with, and then how many digits do you keep? If you start dropping the digits, your answers are going to be off. But I guess that depends on your teacher. So I like to always keep it just as fraction because it doesn't break down the actual number. You get the true values. So now that we have y, I can take this y and then substitute it in for x. Now I can substitute it for any x I like. All right, so it doesn't matter which one I substitute into. So let's substitute into this one. All right, so I'm going to get 20x minus 15. This is 122. We're going to get a lot of ugly stuff here, but so be it. All right, so this is what I have. Let me simplify this a little bit. And so now 15 and 21. So the 3, so notice I can reduce this by 3. So that's going to be a 5. This is going to be a 7. But that's pretty much as far as I can push it. So that's going to be minus. Now 5 times 122. I mean, if you're using, I'll try to speed it up. You don't have to use a calculator per se. So this is 610 over that. All right. So now shifting over this to the other side. So this is 3 plus 610 over 7. So equals, so 20x. Okay. And now we're going to do, so 3 plus, and I guess we're going to, okay, so put this over that. So 631 over 7. Now, if you can't use a calculator, so don't forget, this 3 is easy to change. Okay, so 3 is 21 over 7, so you have the same common denominators here, right? So 21 plus the 610 is 631. So, I mean, you don't have to use calculators if you don't want to. And then finally divided by 20. So we can divide both sides by 20. So x equals 2. And so division by 20. So 631 over 7 divided by 20. So that's multiplication by the reciprocal. And you get 631 all over 140. And that's your x. So notice, super ugly, right? So for this particular example, our answer for x and y is very, very ugly. So we have this right here, and then we have this right here, which is very, very ugly. Now, it did say interpret what this means. Well, what this means is these two lines are basically passing each other, crossing over at one particular point, and this is the actual point of intersection for this example. All right. Now, for those who kind of want to see, you know, we can take this entire thing back and actually graph it. So I'm going to use the, you know, very kind of convenient here Desmos. All right, the graphing calculator, and then we can graph these lines on it. So it was 0.4x, and of course, you know, I forget 0.4x plus 0.12y, 2.5. Okay, so plus 0.12y equal, y equals 2.5. So that's our first line, and then our second line that we had was, so maybe second line we can, let me do that, 4x minus 3y. So it's 4x minus 3y equals to 3 over 5. All right, and then so that's it. Okay, so this is our point of intersection here. All right, so this is what we had. So notice that's how the lines are actually intersecting, and that's what you find. So 4.507 and then 5.8. And if you change, we kept it, you know, so 122 divided by 21. Okay, so notice that it's 5.80. Okay, and so on. So if you compare it, all right, to the answer there, so that's exactly it. Now, of course, the Desmos has rounded this, right? So they put 5.81 for your y, and this is the actual value, 5.8095, and so on. And then you can just check the x value as well. All right, so for the x value, we had, so 631 divided by 140, all right, which is 4.507. And notice, you know, let's do that check. And then that's what you have there. All right, so let's take a look at that second example now. So in this one, so again, we have kind of fractions here. So let me find the lowest common multiple here. It's going to be 6. So if I multiply this entire thing by 6, so I'm going to get, well, this is going to be 2x right there. This is going to be plus y, and it's going to be 3. Now in the second one, so I have a 5, a 5, and a 5. So that one is much simpler. So we can multiply by 5, and we're going to get 4x plus 2y is equal to 7. So let's use substitution this time around. So let's maybe, okay, I'll take this one right here because I have a y on its own. I can shift that 2x over on the other side. So I'm going to get this. So it's in this slope-intercept form, and now I can just substitute it back in here. So if I substitute it back in there, I'm going to get 4x plus 2. My y is negative 2x plus the 3 is equal to 7. Bringing this 2 inside is going to give me 4x minus 2x. And so that's going to be negative 4x because that's 2 times the 2. And then plus the 6 equals to 7. Notice I have a problem here. So it's going to be 0x. Can bring this over on the other side, which is going to give me 7 minus 6, which is going to be 1. But in any case, I get this. So notice this has no solution. So it's one of the cases where you cannot solve this, because if you try to divide by 0, you're going to get this, which is undefined. And this has no solution. So that means these two lines do not meet. So no solution. So they are basically two parallel lines that never meet. So that's pretty interesting. So let's take a look at the last one, at least from that question number 1, or part 1. So let me take this one right here and then see what happens there. For this one, let's use elimination. You should try both methods so you just really get used to it. All right, so again, we have some fractions. Okay, so I can multiply this by 4. That's going to give me 9x minus 12y is equal to 21. That's that first line multiplied by 4. The second line, so I have the 3's, so I can multiply this actually by 3. So that's going to give me 3x minus 4y equals to 7. So that's that. Now, if I want to use elimination, I can eliminate either or. It doesn't really matter. So notice let's eliminate the x here. So I'm going to multiply this line, the second line, by 3. And that's going to give me 9x minus 12y is equal to, equals 21. So take a look here. These are the same lines. So these two lines are identical. So what you're going to find is, well, now if you tried to, use elimination here, if you're going to try to subtract, in this case, you're just going to get 0x, and then you're going to get 0y, and then you're going to get 0. So because if this happens again, these two lines are actually the same. So you have an infinite number of solutions because they are exactly the same line. All right, so your answer is the line itself. Where do they intersect? They intersect at the line, and then you can pick any of these because they're the same lines. So they intersect at that line because they're just lying right on top of each other. All right, so that's the end of question 1. All right, so that's the part A, B, and C. Let's take a look at some of those word problems. So I'm going to take this, going to be my first word problem. Let's copy it down. And these word problems, these are probably going to challenge you. So try to see if you can solve them on your own. But it gives you a nice perspective of how to set these things up. So you have Sabrina goes on a trip, Toronto to New York. So that trip is 790 kilometers away. Her sister, Isabella, drives from New York, so in the opposite direction. The two sisters pass each other 3 hours, 20 minutes later. All right. So whenever you're stuck, and you're doing these questions, it's nice to kind of draw these things out for yourself. All right. So let's say, here is Sabrina. So this is Toronto. Here is Isabella. Here is New York. Okay. So they're driving in. So one is driving in this direction, one is driving in this direction. Let's assume that they're taking the same path, right? The same route, right? That's what they say there. And now they pass each other. So there's going to be some point. Now, of course, we don't know exactly where that point is. So there's going to be some point that they pass each other. One is going in, this, and the other one is going in this direction. So they're telling us that they pass each other at the time. This is 3 hours and 20 minutes. All right. So you can either keep it in hours or in minutes. Now in the next sentence, it actually says Sabrina's speed. Okay, so let's do that. Sabrina's speed. So speed, so let's say V for velocity or speed. Okay, so that's Sabrina so that's her speed is 37 more than Isabella's. So V Isabella, so more than, so let's do that. And it is in kilometers per hour. So let's keep the time in hours. All right, so 3 hours and 20 minutes. 20 minutes, is, 20 minutes out of 60, that's just 1/3, right? Okay, so that's 1/3 of an hour. So it's 3 hours and 1/3. Okay, so this is 3 and 1/3. If you want to write it as a fraction, then that's what it's going to be. So that's when they pass each other. And now it says, how far has Sabrina traveled when they passed each other? Okay, how far did she travel? So we want to know this distance. Okay, so we want to know that particular distance. So how far is that distance? Now in distances, all right, so distance is just speed times your time. So, Sabrina's distance is equal to her speed multiplied by the time that we have. So multiplied by the time. Now the time is the same for both, right? And then distance of Isabella is her speed times time. Now we know, all right, that they're going to be passing each other at a certain point. So that doesn't change. That's the same. Okay. Now these two distances, so if you take Isabella's distance and then Sabrina's distance, so obviously the two distances have to equal to the total distance, right? Because they're going kind of in the same, and then they're passing each other. So as they pass each other, they cover the entire distance, which is 790 kilometers. So what we have is, we have that distance Sabrina plus distance of Isabella equals to 790. So now notice, now we're starting to have two equations and we want two unknowns. All right. So the distance of Sabrina, so that's right here. Okay, so this is going to be, so 10 over 3, so that's the time multiplied by her speed. This is going to be Vs. Okay, the distance of Isabella is 10 over 3, that's the 3 hours, 20 minutes, and times her speed. Okay, so that's what we have there. So now, those are the distances, all right, that we have. So those distances right here, so this is 10 over 3 Vs plus 10 over 3 Vi is equal to 790. Okay, all this is saying is the two distances added together is going to be 790 kilometers, which is true. Now your second equation, so this one, which is Vs is equal to Vi plus 37, that would be your second equation. Now coming up with that, that's the hard part, right? Now if I gave you this is basically like your X and your Y problem. You know, you can substitute, so here, you know, let this be X. Okay, so Sabrina's speed is X. So that's your X. Then Isabella's is your Y. This is your Y. Now, if someone gave you this, you would know what to do. But that's why the word problems are always hard, because you have to actually kind of set them up. All right, so let's try to solve this. Now, we're going to use a substitution because it's already isolated for X for us. So let's use substitution here. So we have 10 over 3. I'm going to substitute for X. And that's going to be Y plus 37 plus 10 over 3 Y is equal to 790. All right. So that's what we have there. So this gives us, now we can bring this inside of the bracket. So 10 over 3Y plus, this is going to be 370 over 3 plus 10 over 3Y is equal to 790. Now, my Y that I'm solving for, that's again, so remember what I said, Y was just Isabella's speed. Now, once we have Isabella's speed, we can find out what Sabrina's speed is. And then, since they're asking for distance, we can find what the distance is. Because the distance is just your speed times the time, which is 10 over 3, which is 3 hours and 20 minutes. All right, so that's what we need to do. So solving this thing, so we can group these things together, can bring this over to the other side. So I'm going to get 20 over 3y is equal to, this is 790 minus 370 over 3. All right, so that's what we have there. So 790, okay, so we can put 790 minus, and then 70 over 3. Now notice that 3, all right, so this is what we have. Now we got to get rid of this, so we're gonna, okay, so multiply, so let's say 3 over 20, So that gets rid of this, gets rid of that. And now 3 over 20 on the opposite side. So notice the 3 is gone. And then 2000 by, so this is actually 100. So this is 100 kilometers an hour. So that's what Isabella was driving. And that means that Sabrina, so X, which is equal to what Isabella had. So notice, Isabella plus 37. So plus 37 would have been 137 kilometers an hour. That's how far she was. That's how fast she was driving. So what's the distance? Well, her distance is equal to her speed multiplied by the time. And I mean, in terms of if you want to leave it as a fraction, so that's what it's going to be. But let's put that in there. So it's approximately 450, let's say 7 kilometers. That's the distance that she drove. So that's this distance right here. And then that means Isabella covered the rest. Now, because Isabella is going slower, she's not going to cover as much distance. So that's a very hard question. Okay, if you get that and if you understood it, great. I wonder if you actually got it without looking at the solutions. So this one was a pretty good one. And it is literally linear systems. 2 equations, 2 unknowns, and then the setup. So here is now the last one. So it is another chaotic question for you. So let's see how to do this one. Now let's clear the page here. Paste it. So I have done kind of these concentration questions already in the playlist. Maybe I'll put up a link up above here for you in terms of concentrations word problems to get you started. And this is, you know, again, slightly little changed, okay, to see if you can bring things together. So we have a health professional, has one 250 milliliter bottle. Okay, so since these are concentrations, so here is my bottle. So this is 250 milliliters. The concentration is 1/5. Okay, concentration. Now that's the concentration. So 1/5 is like saying 20%. All right, so don't forget that. You can change those to percents if you want. The other one, okay, so there's another. This one has more, 450 milliliters. And this one is 7/10. So that's like 70%. The health professional decides to mix the 2 bottles. Okay, so we're going to be mixing these 2 together. Okay. To produce 150 milliliters. So we're going to produce 150 milliliters of 35% concentration. After the mixture, okay, so 50 milliliters of the 35% concentration was poured back into the 1/5. Ooh, okay. So when we mix this afterwards, we pour it back into there. All right, and we pour back 50 milliliters. Okay, so that's going to be interesting. Okay. How strong is the concentration of the bottle that the health professional poured into? Okay, so now we want to know this because it was 20%. Okay, so this is visually what happens. Now, with these concentrations, so obviously first let's try to find out. All right. Okay, so how much did we have to pour in of each? Because, so here, the trick with this is, because sometimes what people think is, oh, you have 50 milliliters, now you poured it into here, so that's 250 milliliters plus 50, which is 300 milliliters, and then you can get the concentration. Well, that's not true because you poured some of that 250 out. So we want to know how much we've poured out. So let's say this, we poured out X, and then we poured out Y. So how did we solve these concentration ones? Well, so we have, so in terms of concentrations, okay, so we have the following. So it's 20% or 1/5 of X, okay, how much we poured out, plus 7/10. Now you can keep them in decimal if you want, and that produces for us 0.5 times 150, right? So that's what it produced for us. Okay, so that's the concentration, and then that means X plus Y is just 150, which is the total amount that we poured out. Okay, so those are my now 2 equations, 2 unknowns. So this will now tell us, okay, so how much did we pour out? And then after we do that, then we can go back and then find out the rest. Okay, so let's see what that gives us. So first, 0.35 times 150, so that's 52.5. This is 52.5. Okay, and so let me rewrite this. So let me multiply. All right, so I'm going to multiply this by 10. The reason why I'm multiplying, so I can get rid of those fractions and then the decimal. So if I multiply by 10, I'm going to get 2x plus 7y is equal to 525. Okay, so that's the first thing. Now, the second thing that I'll do is I can use pretty much anything I like. I can substitute, or I can multiply this by 2, this particular line, and then I can eliminate. So that's going to be 2x plus 2y is equal to 300. So let's use elimination here. So minus, it's going to be 5y is equal to 525 minus 3. So that's going to be what, 225, I believe. So that's what we have there. Now dividing it by 5, so y is equal to, so 225 divided by 5, I should know that. Ooh. So 5, 4, 20 minus 2, it's 45, right? So 45. Okay, so that's 45 milliliters that we poured out. So that means that X, I can solve for X. So I'm gonna take this, so this line right here. So notice that X, okay, if this is 45, so X is gonna be equal to 150 minus 45, which is actually 105 milliliters. All right. So now you know how much you poured out of here. So you poured out of here, okay, into there. Now, are we done? Almost. Okay, so almost. So notice, so what did we have? So we had, okay, because we're pouring back into here, we had 250 milliliters. And this was 20% concentration, all right, or 1/5. Now we removed, okay, so we removed because we were pouring it out. So what do we have left? Well, we removed 105. So 105 milliliters, because that's X, has been removed. So now we have less. So how much do we have remaining? Well, 250 minus 105. So that's going to be 145 milliliters. So that's how much we have still remaining, okay, of the 20% solution. But what do we do? In here, they tell us that we pour in 50 milliliters of the 35% solution. So notice we pour in here 50 milliliters. All right. So now, okay, so in that 50 milliliters, okay, so we have, this is 0.35. All right. And that is the 50 milliliter solution, okay, plus we have now, and this will be 145, so 0.2, 145 milliliters, Okay, so that's what we have now mixed together. Okay, so now this is what we're gonna set up now. So now once we set this up, then we can get what the new concentration would be. All right, so from both of these. And how do we get the new concentration? Well, remember, so I mean, we do this all the time. So with the new concentrations, when we're pouring two things together, right, when we pour two things together, all we're doing is we're trying, so notice that, so we did it right here. So we poured this, okay, and this together to obtain this. But now they've always told us how much and then what the concentration was. And this time around, we know, because we're pouring two things together, we know how much we have. So right here, so we know how much we have. And this is supposed to be equal to, now we don't know what the concentration is. So our particular concentration multiplied by, now we know the total amount, which is the addition of the two. That's how much we have in total. So now you only have one equation, one unknown. All right, so you have this times this, so we can do that. So 0.35 multiplied by 50. So that's going to be 17.5 plus the other one, which is going to be 0.2 times 145. This is 29, and it is equal to, okay, because in total you're going to have whatever this is times your concentration. So adding these two things together, so we have 17.5 plus 29, that gives me 46.5, dividing by 195 on both sides, okay, and gives you the actual concentration. So the concentration is approximately, say, 23.85%. That's the new concentration, right, that you poured back in. That's a tough question. Another tough question. So the first step, finding these x's and y's, so these were kind of normal. This is now a step further, you know, to try to see if people understand what they were actually doing and they're not just memorizing the step processes that they have. All right, and that was, okay, that's what they wanted. This was a tough quiz. All right, we'll see you in future videos. So if you understood these ones, maybe not on the first go when you tried it, but if you watched over it and you understood it, amazing, great, okay? Bye, everybody.